All right, I'm showing 9 o'clock, so let's go ahead and get started. My name is Mike DeLaCluse, President of Lesman Instrument Company. I'd like to thank all of you for taking time out of your busy schedules to join us for real-time actionable information through wireless technology. Our speaker today is our own, Lesman's own Bob Kakanda. Throughout Bob's 38-year career, he's been involved in designing and implementing HMI applications, SCADA, PLC, and hybrid control systems. After 27 years at Honeywell, Bob joined Lesman as our wireless and controls product specialist. In today's webinar, Bob will cover defining some key criteria for choosing wireless infrastructure, comparing wireless infrastructure and standards, finding the ROI in wireless, benefits of an open standard, and then a little bit about some applications we've done. Just in case you'd like to review the presentation or share it with coworkers, the presentation and slide deck will be published to our website in the next couple of days. We will be muting the phone lines. If you have a question, there is a question tool built in to GoToWebinar. Please send me the question and I'll make sure that we get them answered. With that, I'm going to turn it over to Bob.
Good morning. Again, this is Bob Kakanda. Thank you for attending, and we'll get started with the seminar this morning. And as Mike indicated, it was on the ISA wireless backbone infrastructure and versus sensor networks, and in talking about that infrastructure and how it's driving the demand for wireless sensor technology. So with that, we'll kind of move on here, and looking at the applications. I mean, there really are two basic choices in the marketplace for industrial wireless. Okay, there's network-based infrastructures, which we're going to cover today and look at the differences, and sensor-based architecture. Okay, those are the two major competing solutions as far as the industrial wireless architectures or application solutions that are available in the marketplace. And basically, the one is the ISA100 standard. The sensor-based architecture is wireless HART. Okay, both are major suppliers of industrial sensor technology and wireless industrial technology. So what do we want from this wireless infrastructure? And we want to talk about the infrastructure because it's really key, and it's important as we start to go forward in how you're going to build out the system. Obviously, we're going to try to cover that there's reasons why you're going wireless. I mean, it obviously saves money. We need to be able to build a reliable base of wireless architecture to be able to get the sensor data and get the instrumentation data back in as good as if it was a wired solution. You need, obviously, there's concerns on security. We'll cover the scalability in the system, and we'll talk about the flexibility. So just looking at the market right now, this whole industrial wireless technology market is actually coming into its own realm. It's no longer a leading edge or a bleeding edge technology. Back in 2009, there was a little over $500 million of sensors, of wireless sensors that were sold. Per the latest survey, we're talking about revenues of $1.2 billion in 2014, and it's estimated to reach over $3 billion with a compound annual growth rate of 18%. Like I said, this is getting to be a mature technology, and one that everybody is beginning to embrace and establish it as viable alternatives to wiring instrumentation. So let's talk about the ISA100 infrastructure and wireless technology. The main reason why you're looking at wireless technology, obviously, is it's got to be able to save money. Okay, and how does it save money? In most cases, from past equipment cost alone, okay, the installation of the wiring devices is at least 10 times cheaper to the alternative of putting in wired systems. You don't have to run cables. You don't have to run, if you have to trench to get in conduit. You know, we've got into multiple applications in the past, and the customer comes over there and says, well, I've already got wired out at the site and at the location, and it's already installed, and I don't have to pull it. And listen, every time our recommendation to him is use the wired technology. Okay, it's already there. You've already made the investment in your infrastructure. But if that investment hasn't been made in the infrastructure, and you have to pull cables and you have to trench it, it's going to cost you a lot of dollars. And the cost of the incremental cost of the wireless transmitters are still going to be significantly lower cost in your project startup. And then literally the time of landing cables, putting them in the equipment cabinet, wringing them out, your engineering time and the cost of reduction just from the wired solution to the wireless is significant. Literally, you can get a wireless system up and running once you've done your interface to your sensors, thermocouples, pressure, vibration, or whatever. The wireless startup time is minimal. It's compared to having to check out all the wiring and checking all the terminations. So I think everybody kind of realizes that there's a significant time savings, and that's money savings. And obviously, if you have to trench and pull in wires and cables, there's some significant cost to be had there. Okay, let's look at the wireless network technologies that are right now versus the ISA100. Okay, if you look at the current technology that is executed by in wireless HART, it is a peer-to-peer network. Okay, I don't know if you even want to call it a network, but it is a peer-to-peer communication system, and it's based upon about each of the sensor-based systems. So I would call it a sensor-based network that allows the system to build a mesh network, okay, from sensor to sensor. If you take a look at the little diagram we have here over in the corner, if you were to build a wired solution right now in the marketplace for your office, for your plant, for your facilities, there's no way you would have your one PC talking to another PC, talking to a third PC, okay, to get back up into your server and your communication system. The PC goes away and the system's got to be reconfigured. Okay, even if it's a multi-connected system, there's the additional latency time of communications, of getting data and information from one PC through the other PC. It has to acknowledge it, it has to retransmit it. So nobody builds network technology the way the sensor-based wireless system exists today. So networking, the network topologies that were sensor-based went away years ago, okay? Doesn't exist. So we kind of liken this to the bike with square wheels, okay? Now if you look at the one wireless network technology, or the ISA100 11A technology, it uses best practices. It uses standard networking principles. It uses a backbone architecture, which is the correct way to implement the network. I mean, this is how you would typically implement your wired system of you take a PC, you go into a switch, you take it up into routers, and you take it up to the server. And now you're communicating out on the network and away you go. Or whether you're going back down into your control system to email servers or web servers. In this case, you've even set up redundant paths and dual paths going back from switches through routers back up into the server technology. Oh, let me go back one. If you look at the equivalent of wireless technology that is based upon the ISA 111A standard, it's identically the same solution. Instead of PCs, you're talking about sensors. Oh, where'd my mouse go? There it is. You're talking about sensors instead of PCs, industrial sensors, going up into, in this case, you don't need switches because wireless allows you to eliminate the switches. But you'll notice that there's dual path. The industrial wireless per 11A tries to establish dual path communications back over to the routers. Okay, so in this case, you've got your server up on top. I can't even get that mouse to go.
I just move it and it should show up.
I am. Oh, there it is. Okay, so up here at my server, I've got a couple of hardwired connections into routers going out to a mesh network of routers, and you'll notice that all of the routers themselves try to form and will form dual paths back to wired connections back up into your server. Oop, going the wrong way. At the same time, if you look at the PCs going into routing devices, okay, and the routing device in our case is an FDAP, a field device access point. It's just a router, very much like the router on the wired system. And now I have my instrumentation, my PCs trying to find dual paths, identified routers back up into my wired network architecture, back into my server. So the wireless architecture per ISA100 absolutely models current state-of-the-art network technology of going from devices to switches to routers back up into servers. And that's really the point of that slide. The significant advantages, or we wanted to talk about reliability, is now that you have a true network, okay, and you don't have devices communicating through another device, communicating through a third device to get back into your server system, you truly have a deterministic mesh system. The controller, or the server in this case, which in our solution, it's called a wireless device manager, it takes charge of all of the time sequencing. It knows when that transmitter is supposed to talk to that router, okay? It knows that this transmitter is going to try to establish communication with that router, and it's also going to try to find a dual path simultaneously to get back to the device manager in the system. And this guy knows that this is his primary path and that this is a secondary path, and it'll automatically determine which path is the right one to choose. Okay? It'll pick the primary path, and it'll, based on the communication network, but all of the instrumentation data coming from that transmitter is simultaneously dual cast at its time slot back to the system. So it's the wireless device manager is going to determine what its primary path is with the minimum amount of hops to get back into the wireless device manager. So in this case, it says, no, I don't need to go out to a secondary hop to come back in here. My primary path is through this router back into my device manager. And it establishes the time synchronization to let him know when it's talking. So it truly is a deterministic mesh. It's not reliant upon secondary devices that may or may not be the correct path of connection that you have in a sensor type network. What we just talked about here, and this one is a system that, in this case, what we have is a routing FDAP, and then we have access points which are network connected. So then what we have down here is sensors that literally will try to find two paths to get back to the wired sensor network, or the wired server network, back for the WDM. So in this case, even this transmitter down here, 701, let them be pressure, temperature, vibration, acoustic, whatever, he sits there and says, oh, I've got a router sitting up here, right here in the center, but I can get to a access point which is wired into the system through this route, and then through this route if it's in range, okay, and it will choose the communication path to dual cast to the wired network architecture rather than going through a routing device, because it adds a hop to the system, which increases latency time in the overall system. And all of that's managed by the wireless device manager that's running the architecture. So it creates redundant paths automatically, and it creates the sensors automatically dual cast to multiple access points or routers, okay, automatically in the system. Again, talking about reliability, that router or access point that we talked about, in our case, which is a field device access point, the FDM, that's this dual antenna device down here, also employs a patented Honeywell technology, which is called diversity, or dual antennas. The diversity antenna says that these antennas are exactly at quarter wave or half wave, I don't know which one, okay, but it's at a fixed frequency for the 2.5 gigahertz. And so now if I've got a transmitter out here and it's got a reflected signal off the FDAP to the FDAP, and it has a direct signal to the FDAP, it's able to distinguish the reflected signal based on time and an internal algorithm that's running inside the FDAP of what is the primary signal coming from the transmitter versus a secondary reflected signal, because it's bouncing off a tank or it's bouncing off a press, okay? And one of the problems that existed with the wireless technology in the early days, if you didn't have diversity in your antennas, you ended up getting reflected signals, which then had a tendency to lower the signal quality of the signal that you were getting. So you're getting redundant transmissions, or you get a reflected transmission and you get a primary transmission, and the receiving device ended up getting confused in many cases. And it took it a while to figure that out. And that's why it's important when you look at your network architecture, you're going to look at the power of the signal, namely the signal strength, and it's designated by the RSII, okay? But you also need to look at the signal quality and whether it can distinguish reflected signals, background noise, okay, versus the primary communication. So with diversity antennas and diversity on the powered routers or access points, you have the ability now to increase reliability and tolerate multi-path communications. Everybody's worried about security wirelessly. They're saying, gee, somebody can come out there with a sniffer, find out who's communicating. Well, all of the authorization and authentication of the transmitters themselves are executed in the case of the ISA100 11A standard with the wireless device manager, or as it relates to the server, right? It controls all of the keys, and it can be accomplished either over the air, interacting with the operating engineer or the control engineer up on the wireless device system, okay, to allow and says, yes, I just brought out a new device. I want that device to be conditioned. It's automatically found in the network, but it's not put into the network architecture until it's acknowledged and the operator has now identified it, okay, as a legitimate device. The other alternative is you can get a set of keys, put it into a handheld pocket PC, okay, and provide the keys via the infrared port. So all of the keys are designated per the system and then acknowledged it. It then brings it into the architecture, and it's completely secured within the One Wireless ISA 100 11A standard. It then goes through its own set of encrypted data. The ISA 100 11A network does 128-bit AES encryption. It's approved by the U.S. National Security, NSA, for the same encryption that's used for commercial banking. The data is encrypted at the source and it's decrypted at the destination. So there's end-to-end security encryption, and ISA goes one step farther. Okay, it actually uses a 7-layer system, which is the same security as you have on the internet, where it has another level of encryption, which is down at the data link. So the transport gives you end-to-end security, and then on the data link, okay, the security allows you to do encryption and encryption on the individual hops. So if I have a transmitter talking to a router and a router talking back to my server, there actually is a secondary level of data link security that's built into the ISA100 standard. Okay? That's not available in sensor-based technology or sensor-based network. Okay? Scalability. All right? We talked about that as an important point. The Honeywell, or I don't want to say necessarily Honeywell, the ISA100 wireless standard uses IPv6 on all of its field network designation when it establishes its IP address. Well, what does that mean? Well, the Internet of Things, the next technology, the next wave, that's where it's going. Internet protocol addressing in IPv6 gets you 3.4 times 10 to the 38 addressing capability. Well, why do you think wireless technology went with IPv6 rather than the standard subnet of 100 points on IPv4, right? So last year, the Honeywell One wireless system, and I believe all of the ISA100 instruments supplier provided, have now increased their capacities up to 250 devices because they're not limited to the subnets of IPv4. Okay? So what does that mean? Because you remember we now have a true network infrastructure, okay? You have the capability of doing update rates, real-time updates, on 100 devices at one time per second. You can do once per second and mix them at 5, 10, 30, 60 seconds, so I can go 50 at 1 second, 200 at the other rates, or if I'm just going at 5, 10, or 30 second update rates on my individual transmitters, I can put 250 instruments out on the field network. The network expansion is simple. All I have to do is expand the cloud, put in another access point. It automatically extends my mesh network up at the router level, okay? And I just expanded the wireless coverage and I can add additional points. You can't do that with peer-to-peer sensor network technology. So what are we really saying? When you look at the economy of scales, when you want to deploy additional instrumentation into your system, once you've got a true network wireless architecture, your cost per point goes down significantly. Your investment is up front in putting in the network architecture, so now I can add transmitters. And in this case, sure, if I'm putting one wireless transmitter on an architecture and you're building a true architecture, okay, a network architecture, it's going to cost you. You got to make the investment to put the architecture in. But now if I wanted to add 10 more, 50 more points, 100 more points, I don't have to rebuild that architecture anymore. I have the system. It becomes very, very cost effective. And that's why wireless technology is taking off. I need to be flexible, okay? In a flexible design, there's no manual setup. I let my device manager sense my routers, okay, up on the network. It establishes them automatically. It then adds the transmitters. The transmitters automatically dual cast to the routers. It finds the minimum number of hops, okay, completely forming a self-healing network architecture that doesn't require it to go through multiple sensors to get back into my control system. So the minimum number of hops. Now, yes, these transmitters could in fact be routers, okay? So if you need a routing device to be executed down at the sensor level, yeah, we can do that, okay? But even if you selected it as a router and it found a fewer hop point back to my server, it would choose that path and it would never use the routing transmitter. So flexibility of design, okay, is key, and you've already paid for it with the investment with ISA100 technology. Okay? So literally adding another access point. In this case, these were my wired access points. This one is a routing access point, and all of these devices are powered. The advantage is now I don't have one transmitter trying to talk to another transmitter, chewing up battery power on industrial wireless transmitters, because it'll dual cast to powered routers. We talk about the economy of scale where we added hundreds of transmitters, can you imagine going out there replacing batteries on hundreds of transmitters? Okay, and with ISA standard ISA100 instruments, most of the batteries that are implemented are off the shelf, and on all the Honeywell transmitters, they're off the shelf batteries. Okay, so flexible, open standard ISA100 allows you to bring in multiple communication protocols. The sensor-based network is tied to wireless HART. You can't bring in any other protocols across that network architecture. That's it. So for example, if you were to wanting to add a Enroth radar gauge onto the system that communicates via the Enroth protocol, the ISA network allows for block transfer of information to be tunneled over the ISA100 network. What that allows you to do is allows you to not be necessarily invested in just the technology of sensor-based data, but allows you to be able to do block transfers of communication and to be interoperable across all of the ISA certified devices. So for example, I'll show you an instrumentation, the SKOFF vibration transmitters, okay? Well, they adhere to the ISA100 certified device. Their vibration sensors and their transmitters and their temperature sensors show up just like a standard ISA instrument. But also, if you wanted to do high-frequency vibration analysis down at the bearings on a motor or a pump, okay, that requires a significantly large amount of data, high-speed data acquisition that then gets burst over through the system, tunnels through the ISA100 wireless system, and then goes back into the operating system that SKOFF has that provides to be able to do Fourier analysis on the vibration. So block transfers of high-speed data can in fact be accommodated so you can support HART, so you can support Profibus, so you can support Foundation Field Bus network architectures over the ISA100 network architecture. Okay? So it's an open standard that anybody can jump onto. 75 years ago, Honeywell said 4 to 20, and it became a standard. Well, ISA100 is now a standard in the marketplace. It's an open architecture and lots of instrumentation suppliers. Okay, so you can now bring in multiple suppliers from multiple devices. If you don't like this particular sensor, wireless sensor transmitter, you can go to the competition. If it's certified under WINSA, which is the WSI certification body for the ISA100 standard, kind of like the HART Foundation or the Foundation Field Bus Foundation. If it's certified, it works. I just bring it in the system, and it'll automatically find itself and self-configure. So any ISA100 devices. So let's talk about some of those, okay? Obviously, I have a preference if you end up using pressure and temperature and universal inputs that you look at the Honeywell solution, since we're a Honeywell distributor, okay? So if you need pressure, gauge, differential, absolute pressure, pressure transmitters, you need RTD thermocouples, millivolts, digital inputs, wireless sensors. If you need high-level analog, 1 to 5, 4 to 20, And by the way, all of the sensors, in most cases, are multiple inputs per sensor, so that it's not just one input per transmitter. So you can get 3 thermocouples, 2 RTDs, 2 4-to-20s or 3 4-to-20s, plus a digital output, okay, on individual wireless sensors. If you have the need for precision custody transfer tank gauging, okay, the Enroth solution has a radar that allows you to be able to get custody transfer level measurements in tank systems. Enroth also has their standard servo gauge, which is essentially a de facto standard for servo measurements, for precision measurements in tanks, where you have an enclosed system and you can't use radar. And Enroth and Honeywell has developed a wireless field interface that I can now read the biphase mark signal coming from the gauge, the servo gauge transmitters, and transmits it over the ISA100 standard. Wireless communication can be read within the system. We talked about this solution that was brought out by SKOFF. This particular wireless transmitter is intended for semi-critical balancing plant assets, measuring vibration and temperature. It has 4 vibration transmitters, 4 temperature transmitters, and then it also, as I said, transmits a tunneled once-a-day high-speed block of data back into the SKOFF system to be able to do Fourier analysis, so you can look at potential vibration that's even occurring down into an individual bearing on a pump or on a blower. Okay, so for doing preventative maintenance, where you literally had to plug in vibration transmitters or walk around the plant, you can literally do that with wireless technology. Along the same lines, limit switches. What you're looking at here is a Honeywell micro switch, limit switch, wireless technology, ISA100. The one up on top, if you look at it, has a little tiny button up here that I could have, for example, for a door closure or for any place where I'm making a connection. But I can also change the interface on this device, it's just a switch, and make it be a detector at a valve position, so I can verify that the valve truly traveled and I didn't have a linkage problem from my drive. So I can do verification. I can utilize the limit switch technologies tied over to a pull chain on a safety shower or an eyewash solution. Okay? And remember, per OSHA requirements, you needed to be able to update that within a second. So these are once-a-second monitored points to meet the OSHA requirements, to be able to know that I've got a man who just pulled a safety shower solution in the marketplace. Okay? So, sensor switches. Honeywell's just brought out through the microswitch group a lower cost gauge pressure transmitters. So for the cases where you would say, oh, geez, I'd like to have a pressure indicator, and what I would put in is typically a dial or rotary type device sitting monitoring pressure. Now I have a low-cost solution that will give me local indication, and by the way, I don't even have to walk out there and look at the dial, at the gauge. I can get it wirelessly back into my control system. The same thing applies with the Honeywell Analytics. This happens to be a stationary gas detector, okay, with you select the type of gas detection that you need for LEL or LFL type of application, for carbon, for any one of the gases that are available. And in this case, we communicate with that device with the HART protocol with our OWA, and our OWA is just a device that sniffs the HART signals and brings out the primary, secondary, tertiary, and fourth variable off the HART signals on the transmitter. Okay. We even have corrosion monitoring, okay, utilizing Honeywell corrosion monitoring, so you can get corrosion rate, pitting factors, B values, If you want to, if you have a rotary valve, and I now need to know what the rotation is, this device, the XWire 6000 position sensor, will literally clamp onto the valve and allow you to know the exact position of the valve, so I can get feedback again to verify that my linkage didn't go, that my screw isn't tight, or I'm not slipping. The one wireless adapter, which we utilized, on, for example, on the Honeywell Analytics stationary detector, again, brings out the primary, secondary, tertiary, and fourth variable right off a heart device. So it reads the heart signal, that generates it, and converts it to ISA100 communication. Now, I don't necessarily want to suggest, but they're totally interoperable. There's lots of suppliers out there that provide other instruments. There's a microcore device that literally from Casasco microcore that allows you to be able to do corrosion measurement, kind of like the Honeywell solution. But here's one that's competitor. And if you prefer Rohrbeck Casasco, you bring the device, it's now ISA100 certified, you bring it into your system, you commission it, and you're reading the process variables wirelessly back into your system. I even have one over here from Yokogawa, okay, because I thought it was really a neat device. And they, by the way, they do support the ISA100 standard, okay, for all of the types of devices that we talked about, okay. But this one was actually pretty neat, where it actually allowed you to bring in HART protocol or Modbus protocol, okay. So it's tunneling across the ISA100 network, so I can bring in RS-485 into the transmitter and bring out RS-485 at the other end at the WDM, or the wireless device manager, okay. Simple tunneling with sensor technology. I obviously could have spent a lot more time and put all of Yokogawa's devices on that. Forgive me that I didn't do that, since we're not one of their distributors, okay. Flowserve, for example, also has another positioning sensor device, okay. It allows you to be able to measure the exact position of the valve, or their valve that couples onto their shaft, so I now know the exact location of the device, and I'm getting feedback into my control system. Didn't want to leave out GE Bentley, Nevada. And this one's significant because if I'm doing vibration, their vSIM module allows you to be able to do four vibration sensors and 4 temperature sensors, okay, with mix and match temperature types. So I have accelerometers. It goes back to the GE System 1 system, but all of that data is tunneled over the ISA100 infrastructure. So GE Bentley, Nevada utilizes the ISA100 standard to communicate the high-speed data from vibration analysis. And by the way, this one is actually Class 1 Div 1 certified. Okay, Armstrong has just released the ISA100 compatible steam trap monitor, and there's also one from Sporadic Sarco. They also do steam trap monitoring, so they have the integral sensor. So if I've got steam leakage, or if I've got a clogged steam line, okay, I can monitor my steam traps wirelessly, and I don't have to go out there and do a survey. So you can go up to the ISA100 site. Okay, this one happens to list all of the people that are supplying ISA100 certified instrumentation. And again, you can bring those into any one wireless ISA100 standard system. So again, Honeywell, Bentley, Nevada, Flowserve, Casasco, SKF, Yokogawa. Okay. So why is the ISA100 network the best in the marketplace? Because it's flexible. I can select the solution. I can satisfy my application. I can use ISA100 as a user choice. I can select the type of wireless coverage that I want. I can expand it within my facilities. I can mix and match transmitters from multiple suppliers. I have performance, okay, with a powered infrastructure, so I'm not changing batteries. I can go from 100 transmitters to thousands of transmitters on my system, okay. I can get once per second update rates. I can expand my battery life on hundreds of transmitters. Depending upon the you're talking about, if you go once per second, you may be talking about a battery life of 2 years. If you're going once every 30 to 60 seconds, you may be talking about 10 years of battery life. It has the longest transmission data rate, and it has a diversified radio, okay, with the FDAP, with diversity antenna. It has over-the-air firmware upgrades, so I don't have to do that individual. I don't have to, if I get an upgrade in the system that improves the technology, expands the number of points that can be added in the system, I do that upgrade wirelessly, and that's not offered by competition, okay, especially over on a sensor-based network. You have to go out there and individually upgrade all of the transmitter. It's easy to use, okay. The interface is intuitive. It generates reports, gives you systems health monitoring, alarms on all of the device. You have over-the-air firmware upgrades, and it's life is much easier with one wireless, okay, or really with the ISA100 standard. So I have a powered infrastructure, longer battery life. I have increased range. I've got over-the-air upgrades. I've got a single network to manage and maintain with a single company that can support all of and everybody else's instrumentation that is available for the ISA100 standard. I've done a lot of talking.
Do we have any questions? As we wrap up, if you have any questions, please feel free to send them to us over the chat tool that's built into GoToWebinar. If for some reason we conclude this session before you get your question answered, feel free to contact myself or Bob. Our emails are fairly easy to remember. Bob's is bobk@lesman.com. Mine is miked@lesman.com. At this point, Bob, I want to thank you very much for the presentation. Again, if you do have any specific application questions, feel free to give us a call, 800-9-LESMAN or 800-953-7626. Bob, I'm going to take back over here.
Okay, you got it.
Let's see.
Again, thank you.
Show my screen. Oops. What happened here? Is it showing?
Yeah, I got you. It was
okay.
Small.
There we go. All right. If you want to know more about some of the technologies we supply, please follow us on social media, and we've got them up there. Dan Wisey is our other technical specialist. Dan's blog is very active and has tons of great tips. All of our webinars are posted both on our website and on our Lesman Instrument Co. YouTube channel. So if you just went to YouTube and typed in Lesman Instrument, our channel would come up and all of our videos would be there. If you want to know when something new is posted, please follow us on LinkedIn or Twitter. We do have a question. What if you have a device such as a pump stroke length actuator that is not wireless? If it has hard on it, or has, well, no, we can take it in if it has 4 to 20 milliamp.
Sure. I mean, you can look at the actuator either from 4 to 20 milliamp, as Mike just indicated. So we can actually monitor if it has 4 to 20 milliamp out. If it has a protocol on it, let's say HART on the device, we could read the status off the HART signals themselves with the one wireless adapter and transmit it over the ISA network. We could read the 4 to 20. If it's a pump stroke actuator, that's a pump that just moves back and forth?
I don't exactly know what that is, but I'm assuming there's some indication as to where it's at.
Yeah. I would think that's moving pretty rapidly, so you probably wouldn't want to put a switch on it that's moving up and down. So I'm assuming that the two choices in that case would be either a 4 to 20 milliamp signal if it's operating properly, or if it has a HART communications on the device itself, we could read those data.
Or any communications.
Or any communications, yeah.
We can pull it out.
I hope that answers the question.
You can see from the screen, next month's webinar topic is going to be presented by Jim Heafy of Sartorius Intech. That's going to be on May 12th. Jim is going to go over the basics of tank weighing. He'll fill you in on how load cells work, the best way to apply them, and how to get the most accurate results. At this point, we don't have any further questions, so we'll go ahead and conclude the webinar. Thank you very much for attending, and thank you very much for taking time out of your busy schedules to hear us.
Thank you.